Okay, let's talk about useMemo hook of React and how it can speed up your React application. Now, conceptually, this hook is quite simple and it is quite powerful, but not a lot of people use it. And I think the main reason is lack of understanding of the fundamentals of memoization in general. So let's address that before jumping into React code. Let's understand these fundamentals. Now, in computer science, the concept of memoization is basically an optimization technique used to speed up your application. Or more specifically, it is a technique that helps you to avoid redundant operations, which obviously improves performance. So here's a simple example that will help you understand this concept. We have a simple array of integers, just integer numbers, nothing fancy. Let's say your task is to calculate factorial number for each integer in this array. Now, factorial is a number, it is a very simple concept in math. Let's say factorial of 5 would be 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by 5. This is factorial of 5. Nothing difficult, it is a very simple concept. So here's a very simple function to calculate that. Don't overthink this function. This is not the focus of the concept of memoization. This is just an example of an expensive operation. Expensive operation means some kind of operation that will require a lot of resources, a lot of time. It is an operation that is not going to give you an instant result. Here we have a loop from 1 to the n number, which we get here, and basically calculate the factorial and return it, right? Okay, so we have the array, we have the function. Now, factorials, I'm going to define a new constant here, which is supposed to be an array as the result. So what I'm going to do is take the original array and use map and get the integer and call get factorial of that number, that integer, and then simply console log the factorials. Now, let's check out the console. First of all, this is the final array, right? These are the factorials of for each number. So the important part here is that, let's say we have 8 items in this array, right? We see the console log, this one, also 8 times, right? So get factorial function was called 8 times in general, 8 integers, right? Now, the problem here is that 15 is repeated, 17 is also repeated, and as we said, calculating factorial is quite an expensive operation. The numbers are huge. Looping through the numbers from 1 to 17 twice doesn't really seem logical, right? This is the number which represents factorial of 15, right? But this number is the same. Why? Because the input number is the same. So we are performing a redundant operation, which obviously doesn't make any sense. We are using too much resources to calculate the same values. So wouldn't it be great if we had some kind of cache to store already calculated values? Like, this is a simple object, right? Nothing fancy. So let's say I calculate the value of the number 15, and it's some kind of number. I store it here. Then I go to the next number, 12. I calculate the value and also store it here. So basically, we would cache already calculated values, right? And as we iterate through original array, what we could do is check if we already have the value or we actually need to calculate it. So let's empty this cache object and add just a couple of lines of code here. Let's get rid of this console. It really annoys me. And here, curly brackets and a return. Let's add a simple conditional that would check if this number already exists in this cache, and if it does, return it. And otherwise, we would just calculate this number from scratch. Now, this cache is empty initially, so as you can see, the function has been called 8 times. It's basically the same as we had before. Obviously, this happens because we have the conditional which checks if the value for this particular integer exists, but we don't have anything to store new calculations, right? So again, very simple. Cache for this particular integer equals get factorial, and here simply return the same value. So now something interesting happens. In the final array, we have 8 elements as we had before, but you can see that there are 6 console statements, not 8. We actually used memoization technique. What we did is that we performed some kind of expensive operation for each unique numbers only. We didn't run the same operation over and over. We didn't perform redundant operations. So again, we only have 8 integers here. In a real life scenario, you might have thousands of items, or you might have some kind of tree, some kind of complex structure, some kind of complex input data, right? So obviously memoization gets more and more relevant as the complexity of your input data increases. Adding just a few lines of code, we leveraged memoization. Okay, now that we have understanding of the concept of memoization, let's go back to React code and understand useMemo hook, how to use it, when to use it, and so on. But before I forget, hit that like button and subscribe. So we are going to continue with the example of calculating factorials. And for that, I actually wrote a simple React component with some UI elements. Basically, the user can input an integer here and calculate factorials, right? Nothing too fancy. Under the hood, it's the same utility function to calculate factorials. And it is used here in this memo component. We have the simple input, which on change triggers this handler function, which gets the value here and basically uses this set number to store the number as a state of this component, right? And then we have this factorial as a constant, which is basically the same as we did before. Call that function, provide it with the number, and then use this number here, right? Nothing difficult. It's just the same as we did before, but with some UI elements and some interactivity, right? Okay, now let's say I want to calculate factorial of 15, right? I change this input number and I see console statement. I see the number has been calculated. But as you can see, we also have this re-render button. Let me show you what it actually does. Here is the button. It has this on-click handler, which we can see here. And as you can see from the logic, it basically increments this number here. Nothing difficult. It just increments the number. So let's click this button, right? I clicked it. I clicked it again. So I basically force the component to re-render, right? But what we are seeing is that this function is also called again, right? We are not changing the input number. The final calculation of the factorial is not different, but this function is called again and again. So here we are actually performing redundant operations. The number doesn't change, the result doesn't change, but we call the same function with the same input again and again. Doesn't really make sense, right? And in this case, it's quite simple, but as I said, it might be something very, very complex, and it really might affect performance of your application. So this is where useMemo becomes relevant. And it is very simple. So remember what we did with the general explanation of memoization? Basically, we added a couple of lines of code which helped us to avoid redundant operations, right? So in React, useMemo hook basically performs the same role. Very simple. Let's first cut this. Don't remove it because we're going to need it. useMemo, parentheses, an arrow function, paste what we had before, a comma, and here's the interesting part. We have an array with number. Now, let me explain what this means. Basically, this is going to be executed only if one of the items in the array of dependencies changes. In this case, we have this number, but it can be something else. Like if you had some other dependencies, you would simply add those dependencies to this array with a comma and the name of that dependency, which could be like some other state-related constant like this one or something else, right? So let's see what it does. Let's say 15. We can see that the function is called, but when I click the re-render, we don't see new console statements here. It basically calculated the factorial for 15 only once. And although we incremented this value here by clicking the button and executing this handler here, it did not recalculate factorial for 15. So it helps us to use resources more efficiently and helps us to avoid these kind of redundant operations. So this was pretty much it. Again, hit that like button and subscribe. We have some exciting content on the way, so stay tuned.